This is Module 7 on fall hazards. This module will cover many different fall hazards that might exist when filming and ways to protect yourself and your workers against them. This material was produced under grant number SH05146-SH9 from the Occupational Safety and Health Administration. It does not necessarily reflect the views or policies of the U.S. Department of Labor, nor does the mention of trade names, commercial products, or organizations imply endorsement by the U.S. government. Falls are among the most common causes of serious work-related injuries and deaths. This includes falls to the next level, as well as slips, trips, and falls on the same level. In 2016, 697 workers died in falls to a lower level, and 48,060 were injured badly enough to require days off work. A worker doesn't have to fall from a high level to suffer fatal injuries. In fact, 134 workers were killed in falls on the same level in 2016. Construction workers are most at risk for fatal falls from height, more than 7 times the rate of other industries. But falls can happen anywhere, even at a desk job. Upon completion of this session, the participant should be able to identify types of fall hazards associated with workplace environments and identify methods to eliminate or protect against fall hazards. Walking working surfaces include all vertical and horizontal surfaces where work is performed, including floors, stairs, roofs, ladders, ramps, scaffolds, and elevated walkways. When we think about a fall, we usually think about a fall off of a piece of equipment or to the next level, but a fall can happen on the same level as well. To prevent slips, trips, and falls, it is important to keep a focus on good housekeeping, training, and appropriate maintenance of equipment. Analyzing the work for hazards is a very important step on any entertainment set. Analyzing the work area for fall hazards may include reviewing plans before work begins, anticipating upcoming fall hazards as work progresses, reviewing for current hazards on site, and pre-planning for fall protection. This is not just analyzing the area for potential falls to the next level, but also slips, trips, and falls on the same level. Everyone is subject to trip hazards on set. Good housekeeping implies that a workplace is kept in an organized, uncluttered, and hazard-free condition. While this is a relatively simple concept, the benefits that can be realized from good housekeeping practices are far-reaching and affect not only workers' safety, but also their health and productivity. Housekeeping requirements include keeping the work area clean, orderly, and sanitary, keeping the work area as dry as feasible, keeping the work area maintained in good condition and free from any hazards, including sharp protruding objects, loose boards, corrosion, spills, snow, or ice. Good housekeeping is not just about cleanliness. It lays the basic foundation for accident and fire prevention. It also requires attention to all details. Slips can be caused from grease, oil, wet paint, water, or other slippery contaminants on floor, spills, or debris. Trips can be caused from poor housekeeping, clutter, loose cords, improper use of floor hole protection covers, power cords, construction materials, or other items in the work area that create a tripping hazard. Filming outdoors can be especially challenging with constantly changing terrain. How do you analyze your work area for fall hazards? Working at heights can be particularly dangerous. It is important to recognize the hazards associated with working from heights and to set up the workplace and use equipment to prevent falls. Remember that falls are 100% preventable. Whether working from a ladder, aerial lift, or scaffolding, it is important to plan ahead, assess the risk, and use the right equipment. Crew members that could be working at heights include set contractors, grips, rigging technicians, lighting designers, production assistants, and many other positions. Think about your position or those that you work adjacent with. Can you think of a time that you had to work at a height or seen someone working at heights? What equipment have you used or have you seen in use? It takes most people about 1/3 of a second to become aware that they are falling. It takes another 1/3 of a second for the body to react, and a body can fall up to 7 feet in that 2/3 of a second. Fall protection is a series of reasonable steps taken to eliminate or control injuries caused by an unintentional fall while accessing or working at height. Employers must set up the workplace to prevent employees from falling off overhead platforms, elevated workstations, or into holes in the floor and walls. To prevent employees from being injured from falls, employers must guard every floor hole into which a worker can accidentally walk using a railing and toe board or a floor hole cover, provide a guardrail and toe board around every elevated open-sided platform, floor, or runway. Regardless of height, if a worker could fall into or onto dangerous machines or equipment, employers must provide guardrails and toe boards to protect workers from falling and getting injured. Other means of fall protection that may be required on certain jobs include safety harness and line, safety nets, stair railings, and handrails. Scaffolds, stairs, ladders, roofs, elevated work surfaces, and uneven terrain are all factors that are considered major fall hazards. What are some fall hazards you have encountered in your workplace? A stairway or ladder must be provided when there is a break of elevation 19 inches or greater. Fall protection must be provided at elevations of 4 feet in general industry workplaces and at 6 feet in the construction industry. Initially, employers must assess the workplace to determine if walking or working surfaces have the necessary strength and structural integrity to safely support the workers. Once it is determined that the work surfaces will safely support the work activity, the employer must determine whether fall protection is required, and if so, select and provide workers with appropriate fall protection systems. A step-by-step approach to fall protection should include the following steps. Determine if walking working surfaces are structurally sound, conduct a fall assessment, eliminate the need for fall protection if possible, select the type of fall protection system needed, develop rescue or retrieval procedures for those types of fall protection if needed, develop an equipment inspection, maintenance, and storage program, provide fall protection training to all affected employees, and monitor the fall protection program. Generally, fall protection can be provided through the use of guardrail systems, safety net systems, or personal fall arrest systems. OSHA refers to these systems as conventional fall protection. Examples of fall protection include passive and active systems. Passive systems are protective systems that do not involve the actions of employees. Active systems include systems and components that require manipulation by employees to make them effective in providing protection. A personal fall arrest system is a system used to safely stop a worker who is falling from a working level. A personal fall arrest system consists of an anchorage, connectors, and a body harness. It also may include a lanyard, deceleration device, lifeline, or suitable combination of these. The PFAS must be installed, used, and maintained according to the manufacturer. All components of a fall arrest system must be inspected before each use and after impact. Promptly rescue employees in the event of a fall or assure that they are able to rescue themselves. Know the ABCs of personal fall arrest systems: anchorages, body harness, and components, including connectors like snap hooks or D-rings, connection points, lanyards, deceleration devices, lifelines, etc. Body harnesses are designed to minimize stress forces on an employee's body in the event of a fall while providing sufficient freedom of movement to allow work to be performed. Harness systems consist of either nylon or polyester components and encompass the entire body. Body belts or safety belts are prohibited for use as part of a personal fall arrest system. A full body harness will evenly distribute weight across the waist, pelvis, and thighs. Lanyards connect the harness to the anchorage point. Vertical lifelines or lanyards must have a minimum breaking strength of 5,000 pounds and be protected against being cut or abraded. Each employee must be attached to a separate vertical lifeline. Lanyards should be attached to a D-ring between the shoulder blades above the employee. There are several types of lanyards that include synthetic webbing, synthetic rope, and shock absorbing. Horizontal lifelines are to be designed, installed, and used under the supervision of a qualified person and as part of a complete personal fall arrest system which maintains a safety factor of at least 2. Horizontal lifelines must meet the 5,000 pound strength requirement per employee anchored to the system. Caution: guardrail systems and horizontal lifeline systems are not the same thing. Guardrails must withstand only a 200-pound force, and tying off to a guardrail system can be deadly. Anchorages used for attachment of personal fall arrest equipment must be independent of any anchorage being used to support or suspend platforms and capable of supporting at least 5,000 pounds per employee attached. The anchorage point is most effective when it is above the employee's head. It must be located as to not allow an employee to fall more than 6 feet. All anchorage points must be a solid, immovable object that is capable of supporting the 5,000 pounds and must not be used to support anything else. Is the picture on the left an appropriate anchorage point? Why would the picture on the right be a better anchorage point? As you can see on the picture on the right, anchorage points have been designed into the roof system. Improper anchorage points can be a matter of life and death. Improper anchorage points include standard guardrails, railings, ladders, scaffoldings, light fixtures, ductwork or pipes, cable trays, another lanyard, roof stacks, vents or fans, and anything else you are not 100% sure of. Inspect systems before each use for wear, damage, and other deterioration, and remove defective components from service. Equipment must be inspected before each use for degradation due to ultraviolet light, tears, or other wear, deformed eyelets, D-rings, or other parts, labels, placards, dirt, grease, and oil, or any other condition that is not normal. Remove systems and components from service immediately if they have been subjected to a fall impact, until inspected by a competent person and deemed undamaged and suitable for use. Total fall distance must be calculated accurately. A free fall is equal to 6 feet maximum. Deceleration distance could be up to 3.5 feet maximum. Lifeline elongation could be 2 feet. Therefore, the total fall before stopping is 11.5 feet. The portion of the body landing below the attachment point could be approximately 5 feet. Therefore, the total clearance below required to avoid contacting the lower level may be as great as 16.5 feet or more. All employees exposed to fall hazards must receive training by a competent person that addresses the nature of fall hazards in the work area, procedures for erecting, maintaining, disassembling, and inspecting fall arrest equipment, and the use and operation of fall arrest equipment. Retraining is required when there are changes in the workplace, there are changes in the type of fall protection used, or there are inadequacies in the employee's skills. Working on and around stairways and ladders is hazardous. Stairways and ladders are major sources of injuries and fatalities, and many of the injuries are serious enough to require time off the job. These hazards can be eliminated or substantially reduced by following good safety practices. When there is a break in elevation of 19 inches, 48 centimeters, or more, and no ramp, runway, embankment, or personal hoist is available, employers must provide a stairway or ladder at all worker points of access. In these photos, is this the best use of materials? What would be a more suitable way to access the next level and complete the task? Portable ladders come in many materials, shapes, and sizes. Make sure to know which ladder is best suited for the task at hand. Also ensure to read all manufacturer labels and follow all manufacturer recommendations. Self-supporting ladders include step ladders, platform ladders, trestle ladders, or other fold-out types. Non-self-supporting ladders include extension ladders or other leaning types. A stepladder is a portable self-supporting A-frame ladder. It has 2 front side rails and 2 rear side rails. Generally, there are more steps mounted between the front side rails and bracing between the rear side rails. Common stepladder hazards include damaged stepladders, ladders on slippery or unstable surfaces, unlocked ladder spreaders, standing on the top step or top cap, loading ladder beyond the rated load, ladders in high traffic locations, reaching outside the ladder side rails, and ladders in close proximity to electrical wiring or equipment. Extension ladders are non-self-supporting ladders. Extend side rails of portable ladders 3 feet above the upper landing surface. When extension is not possible, secure the ladder and provide a grasping device to assist workers in mounting or dismounting the ladder. A ladder extension must not deflect under a load that would cause the ladder to slip off its support. Keep ladders free of oil, grease, and other slippery substances. Do not exceed the maximum intended load of a ladder or the manufacturer's rated capacity. Use ladders only for the purpose for which they were designed. Angle non-self-supporting ladders so the horizontal distance from the top support to the foot of the ladder is 1/4 the working length of the ladder. Job-made wooden ladders should have an angle that equals about 1/8 the working length. Ladders should extend 3 feet above the landing surface. A 4-to-1 ratio should be used to set up ladders. Do not exceed the maximum intended load of a ladder or the manufacturer's rated capacity. Here are some additional OSHA standards that are important to follow. Each employee uses at least one hand to grasp the ladder when climbing up and down, and no employee carries any object or load that could cause the employee to lose balance and fall while climbing up or down the ladder. Think about the following questions for a moment. How would you approach the situation in each of these photos? And are these the right ladder choices for the tasks? The rules covering stairways and their components generally depend on how and when stairs are used. Specifically, there are rules for stairs used during construction and stairs used only temporarily during construction, as well as rules governing stair rails and handrails. Stairways with 4 or more risers need a railing system, even if they are for temporary use. All parts of the stairway system must be free from hazardous projections. Does the stairway in this photo need a railing? Yes, because it has 5 risers. Guardrails are the most common form of fall protection. They may be made of wood, pipe, structural steel, or wire rope. Flags must be provided on wire rope to increase visibility. To meet OSHA's railing height requirement, the top rail needs to be 42 inches plus or minus 3 inches above the walking working surface. If the vertical opening in the rail is more than 19 inches, then there must be a mid-rail. Install the mid-rail halfway between the top rail and the walking surface. The distance between intermediate vertical members cannot be more than 19 inches. In addition, openings cannot be more than 19 inches wide for other intermediate members such as additional mid-rails and architectural panels. Guardrail systems must be capable of withstanding, without failure, a force of at least 200 pounds applied within 2 inches of the top edge, in any outward or downward direction, at any point along the top edge. Midrails must withstand a force of 150 pounds. The left is a picture of a correctly constructed guardrail system blocking an unfinished elevator shaft, and the right is a correctly built guardrail system around a floor opening. A scaffold is an elevated temporary work platform. There are 2 basic types of scaffolds. Supported scaffolds consist of 1 or more platforms supported by rigid load-bearing members, such as poles, legs, frames, outriggers, etc. Suspended scaffolds are 1 or more platforms suspended by ropes or other non-rigid overhead support. Other types of equipment, principally scissor lifts and aerial lifts, can be regarded as other types of supported scaffolds. Scaffolds used in general industry must meet the requirements in 29 CFR Part 1926, Subpart L. This is the construction standard. There are numerous hazards associated with scaffolds, including falls from elevation due to lack of fall protection, collapse of the scaffold caused by instability or overloading, being struck by falling tools, work materials, or debris, and electrocution due to the proximity of the scaffold to overhead power lines. Slips, unsafe access, lack of fall protection, or failure of the scaffold platforms or planks are factors that lead to fall incidents. Materials, debris, or tools may fall from a scaffold at any time and hit the workers below. Work on scaffolds near power lines exposes workers to electric shock or electrocution. Scaffolds can collapse if not secured, level, or stable, or if they are overloaded. Planks that are in poor condition, cracked with dry rot or otherwise weakened, or planks that are not placed properly are hazardous due to potential for failure or for people or objects to fall through them. Weather conditions like rain, snow, wind, and lightning can cause additional hazards. Collisions or being struck by a construction vehicle or other motor vehicle could lead to tip over. The competent person oversees assembly, disassembly, inspection, and safe use of scaffolds. They must train all employees who erect, disassemble, move, operate, repair, maintain, inspect, or work on scaffolds. The process for designating an employee as the competent person includes having the person appointed by the employer. The competent person must have the capability to identify hazards, they must execute the qualified person's design, and they must have the authority to take prompt corrective action. The left photo shows a frame scaffold, which is a platform or multiple platforms supported on fabricated end frames with integral posts, horizontal bearers, and intermediate members. The middle photo shows a ladder jack scaffold, which is a simple device consisting of a platform resting on brackets attached to a ladder. Ladder jacks are primarily used on lighter loads because of their portability and cost effectiveness. The right photo shows a mobile scaffold, which is an unpowered, portable, caster or wheel-mounted supported scaffold. Scissor lifts are mobile supported scaffold work platforms used to safely move workers vertically and to different locations in a variety of industries, including construction, retail, entertainment, and manufacturing. Scissor lifts are different from aerial lifts because the lifting mechanism moves the work platform straight up and down using crossed beams functioning in a scissor-like fashion. Only trained workers are allowed to use scissor lifts, and employers must make sure that those workers show that they can use a scissor lift properly. Employers must provide workers training on hazards, including how to work safely with or near scissor lifts. Training must, at a minimum, include the correct procedures, the manufacturer's instructions for operating the scissor lift vertically and while in transit, how to handle materials on the scissor lift, including weight limits, and other worksite hazards workers may encounter when working on a scissor lift, like contact with electrical wires. Employers should also train workers in reporting any equipment defects or maintenance needs. Which of these would you prefer to use? The picture on the left is a correctly maintained scissor lift, while the picture on the right is an incorrectly maintained scissor lift. An aerial lift is any vehicle-mounted device used to elevate personnel, including extendable boom platforms, aerial ladders, articulating jointed boom platforms, vertical towers, and any combination of the above. Aerial lifts have replaced ladders and scaffolding on many jobs due to mobility and flexibility. Many workers are injured or killed on aerial lifts each year. The following hazards, among others, can lead to personal injury or death while using aerial lifts: fall from elevated level, objects falling from lifts, tip-overs, ejections from the lift platform, structural failures or collapses, electric shock or electrocutions, entanglement hazards, contact with objects, and contact with ceilings and other overhead objects. Training should include explanations of electrical fall and falling object hazards, procedures for dealing with hazards, recognizing and avoiding unsafe conditions in the work setting, instructions for correct operation of the lift, including maximum intended load and load capacity, demonstrations of the skills and knowledge needed to operate an aerial lift before operating it on the job, when and how to perform inspections, and manufacturer's requirements. Workers should be retrained if any of the following conditions occur: an incident occurs during aerial lift use, workplace hazards involving an aerial lift are discovered, or a different type of aerial lift is used. Employers are also required to retrain workers who they observe operating an aerial lift improperly. What are some hazards associated with the picture? Fall hazards. Workers in the lift must be equipped with personal fall arrest systems. Weather, wind, load of equipment in the lift. Did you find any others? This slide is for use in a class discussion. Think about the following questions. What types of lifts are shown here? Why might you use a lift on a production set? What are some benefits of these versus ladders? Why might a ladder or scaffold work better? In what situations? These are the resources used for this module.